Hello everyone. I hope you all are doing well. In this video, I am going to write a software for a calculator. I'm not going to use any calculator library, but writing complete logic myself. I will need an Arduino, an LCD, and a 4x4 keypad with few jumper cables to build a simple calculator. My focus would be to teach you guys how to write the logic of a customized calculator, and if there are any errors in the software, how to find and fix them. Let's jump over to the goal that we want to achieve with this calculator. We'll map the keypad keys in software exactly in this way that you are looking at this calculator layout. Let's see what this calculator should be capable of. It should be able to subtracting two numbers, adding two numbers, multiplying two numbers, and dividing two numbers. The length of each number should not exceed 7. That means if the number is 8547851, the length is 7, that is allowed. And if the length is 8, that is not allowed. There should be a one C key available on the calculator that should clear the LCD display and also reset the calculator. And there should be one E key that should display the calculations on the LCD. That's all we want to do with this calculator. As you see that, we need only 3 hardware components to make a customized calculator. An Arduino of course, an LCD, and a keypad. You can use any keypad that is available at the moment, but make sure it has enough keys to make a calculator. The keypad that I am using, it has 16 keys. These 16 keys or this keypad has 4 rows and 4 columns. Each row and column is represented or it has a dedicated pin that is connected to the microcontroller. So that's why you see in total there are 8 lines that are connected to the Arduino. Each one is representing one row or one column. On the other side, there is 4 connections that is connected to the LCD. 2 of them, they are the supply. They are providing the supply to the LCD. And these 2 lines, they are representing the I2C communication. I'm using the I2C protocol to communicate data with LCD. The blue line, it is providing the data to the LCD. You see it is connected with the STA. And the gray line is providing the clock to the LCD. The clock is really needed to synchronize the data that is going through this blue line. That's the setup I have prepared. Now let's jump over to the Arduino IDE. Let's start writing the software. The first thing that we need to do is to add the keypad library and the liquid crystal I2C library. The keypad library will help us to read the pressed key on the keypad, and the liquid crystal I2C library will help us to display the keypad results on the LCD. If you don't have any of these libraries installed in your Arduino IDE, please go to the library manager and install them. Using liquid crystal I2C class, I'm creating an object with the name LCD. I have to provide 3 parameters to this object. The first parameter is the LCD I2C device address, and second and third parameter are the number of columns and number of rows of the LCD respectively. Then I'm creating 2 variables that will save the number of rows and number of columns of the keypad. These 2 variables will be used to construct a key matrix in the software. Now let's start constructing the key matrix. In this key matrix, I'm going to construct the rows and columns in the same way keys on the keypad will behave. I'm going to use 4 mathematical operations in this calculator: plus, minus, multiplication, and division. And also creating one key to reset my calculator and naming this key as a C. And the last key would be E, that is representing the enter, and by pressing this key will show the end result of the calculator on the display. In the hardware setup, we have seen that there are 8 Arduino pins which are connected to the keypad. 4 of them are connected to the rows of the keypad and 4 of them are connected to the columns of the keypad. Row pins and column pins need to be specified in different arrays that will be needed later. Until now, we have specified all necessary information regarding keypad. We will use this information to create a custom keypad object from keypad class. It needs 5 parameters in total. First parameter is the key matrix. It represents each character of keypad that needs to be mapped when a key is pressed. Second parameter is the array providing an information of row pins. Third parameter is providing information of column pins. Fourth parameter is representing the total number of rows of keypad. And the last parameter representing the total number of columns of keypad. Now let's jump over to the setup function. In this function, I'm beginning the serial communication just in case if we need to see the results on the serial monitor. It is important to initialize LCD method here. To do that, I'm using a init function and also turning on the backlight of the LCD. As a startup cursor position, I'm setting it to the row 0 and column 0 of the LCD. Let's jump over to the loop function. I'm introducing a custom key parameter that will save the keypad status. The processing of the calculator will only start if any of the keypad key is pressed. Before starting calculator's logical part of the code, we'll need some variables and arrays to define. Let's start defining them. For the simplicity, I'm limiting this calculator to just 2 entries to be processed. I'm creating an enumerated type that contains 3 entries in it. The first number that represents first entry of the calculator, the second number that represents second entry of the calculator, and the reset calculator in case we need to reset our calculator and starting everything as new. Then create one variable of this type and initialize it with first number because that's what our calculator would expect at first. In addition to the previous type definition, we'll also need a definition for the operations. In total, there are 4 possible operations with this calculator. All these operations I'm going to define in this enumeration type, and additionally one more member of this type would be no operation. No operation is a default operation until an operation is requested from the keypad. Then create one variable of this type and initialize it with no operation. We also need few parameters for the calculator processing. Let's start defining them. The one of them is the maximum number length of entries. I'm limiting it to 7 numbers, so that means each entry could be of the length 7, and the length of the number entries more than 7 would not be possible. We need 2 arrays to save the input number entries from the keypad. First array for the first number entry and second array for the second number entry. Each number array is declared with the maximum number length that is set to 7. We can see in the constant declared above. Arduino reads the input from the keypad as characters. These characters will be saved in the respective 2 arrays. Then we need another variable that will save the final number from the array. As we have 2 entries possible, we need 2 variables to save the final 2 numbers. You don't need to panic if you don't understand this concept right now, but you will understand this concept if you watch this video till the end. Along with 2 variables saving final number, we also need 2 position pointers that points towards the next position of number in each array. I'm declaring both of them here and initializing it with 0. Let's jump over to the loop function and start writing the logic for the calculator. Before entering into the state machine and logic of calculator, there are 2 things needs to be considered here. The first thing is that the custom key should have contained one of the value from the matrix that we have created above, which should be not equal to no key, and the custom key should also not be equal to the character C, because the key C is meant to reset the calculator. Now I'll start implementing my state machine. I'm using switch cases because they are quite readable and easy to understand. I'm using calc entry as a parameter to the switch, and then I have multiple cases to differentiate between the first entry and the second entry. Calc entry is initialized with the first number because this is what our calculator is expecting at first. If the first number case is true, then there are also other conditions need to be checked here. The first condition that needs to be checked here is that the length of the first number should not be greater than maximum allowed length. This length we have set to 7 at the beginning. After checking the length of the number, it is also important to see if the first entry is not a mathematical operation. because this is we do not expect as a first number. So we make a check for an addition key, for subtraction key, multiplication key and division key. If a mathematical operator key is pressed as a first key, then this will be neglected. It will not be shown on the LCD and the value also not be saved in the array. Once we have made these checks, we are safe to print the first number to the LCD and also save it into the first number array. I'm also adding one more check here that will only apply if the position pointer of the first number is equal to 0. If that is the case, then clear the LCD and set the cursor to the position 00. Now save this custom key to the first number array at the position pointing by the position pointer of the first number. Remember, custom key still saves the character inside it, and we cannot apply any arithmetical operations on these characters. Let's write a function that will take these characters as an input parameter and return us a real number that we can use to apply our arithmetical operations. I'm going to declare a function here that will tell the compiler the function's name, its return type, and the input parameters. There are two functions I'm declaring here. One to extract the numbers from the characters and the second one to extract the operation from the character. I'll start defining these two functions at the end of this file. One local variable is needed that will return the extracted number to the main function. I'm using switch cases to make a decision depending on the input character. The input character could represent in this function the number from 0 to 9. Then a real number is getting assigned to the result variable. For each character representation, there is one case. I'm being lazy here and copying the case for number 0 and pasting it for all other cases. Just changing the case statement and result of the case. At the end of this function, result variable will return the extracted real number value. Let's start writing the function calculate operation from input. This function takes the operation character as a function parameter and returns back the extracted operation of type double. As I've used in the earlier function, I'm using switch cases in this function again to extract the operation entry from keypad. The first case I'm creating for addition operation, and if the input matches to this character, then I'm going to assign addition member that we have created in customized type definition. And then going to exit from the switch loop. I'm going to repeat the same procedure for the subtraction, multiplication and division. Once the implementation of both these functions is completed, I'm going back to my main function. Here I'm going to use function calculate number from input to fill the first number array and extracting the pressed key value from custom key variable. After extracting this pressed key, print it to the LCD. To track the length and position of first number array, position pointer must be increased. This was the first part of case expression. Now it is needed to check if the custom key has a character of addition, subtraction, multiplication or division. If any of the operator character is saved by the custom key, then I'm going to call function calculate operation from input and providing custom key parameter as an input to this function. This function will then return the requested operator value of type double. To make it more understandable and less erroneous, I'm going to cast the output of this function with operation type and save this return value in variable input operation. After evaluating and saving the requested operator value, I'm going to print it to the LCD. Until now, first number array is filled with the requested number and input operation also saved the requested operator value in it. Now it's time to expect the second number. For that reason, I'm filling calc entry variable with a flag of second number. Now write the break command, that is the last command of any case, and start writing the case of second number. As I have done earlier, verify if the position pointer of second number is less than the maximum allowed length, and also if the custom key is not equal to E, because the key E is meant to show the calculation results, and we cannot show the results just with one number. For that we need to have available second number. Once both these conditions are true, fill the second number array with the pressed numbers from the keypad. Print them to the LCD and raise the position pointer of the second number. After this, we have completed the first part of this case expression. Now we are going to implement the second part of this case expression, where the E key is pressed. That means the calculation results are required. Keep it in mind that the array still contains the individual numbers in it. Now we need to put them together to make a single number out of each array. Now I'm going to write another function that will convert an array of numbers into a single number. This function will need the number array and the length of the number to calculate final number. For example, if an array contains 4 numbers, let's say 7, 4, 3, 2, this function will return then a single number with a value of 7432. We need two local variables in this function. The first one is the result that will return back the end result of this function. And the second one is the multiplier factor. This multiplier factor depends on the length of the position pointer that tells how big the number will be at the end. I'm going to run a for loop that depends on the field entry into that array. With every iteration of for loop, the multiplier factor will be counted and the result gets added with each iteration. And at the end of this for loop, the result will be returned back to the main function. Now I'm using function calculate number from array to get final and real first number. I'm providing first number array with individual number and the position pointer of first number as an input parameters to this function. I'm copying this line for the second number and just changing the parameters here. After writing so much code, let's compile the software and see if it compiles successfully. And we see that there are few errors in the code. Let's try to get rid of them. Okay, the first error is that the m is missing in custom key parameter. Let's write a m here and compile it again. The software did not compile successfully. That means there is another error and I can see that okay, the switch statement does not need any colons here, so get rid of them and compile the software again. Here we see that I is undeclared. That means there is no variable named I. That's a pretty clear error. And instead of I, I'm using CNT as a counter and I'm going to replace I with CNT. And now software did compile successfully. That is pretty normal to make such mistakes during development. And you have seen that how to find and fix the bugs in the code. Let's get back to our main function where we have started the compilation. Finally, we have got two numbers and an operator that we use to calculate our end result. For each input operator, I'm going to use one if-else statement. And depending on the input operation, I'm going to add the final first number and final second number, subtract them, multiply them, or divide them. Now it's time to print the results on the LCD. I'm going to set the cursor to the column 0 and row first. I'm doing that because it is more readable, and at the same time we can see all entries and the end results on the LCD. We can see the final first number, the input operator, final second number, and the end calculation on the LCD. Let's print ans on the LED that represents answer or the final calculation of final first number and final second number. And then finally print the final result to the LCD, that is the end result of our calculator. Once we are done with our result, now it's time to reset the variables that we have used to calculate the final result. Set the position pointer of both arrays to 0. Calc entry to the first number. Input operation to no operation for the next iteration. And at the end of this case expression, break from the switch case. At this point of implementation, there are 15 keys has been covered. You must be wondering, where does the 16th key goes? It's the C key. C key will be used to clear the LCD display and reset our calculator. I'm going to copy the code from above that I have used to reset the parameter values. Clear the LCD by calling clear API from object LCD. That's it. Now I'm going to compile the software. Software compiled successfully. Now let's upload the software on the Arduino board. Software is uploaded successfully. Now let's press the keys on the keypad and see how they react and how they will be displayed on the LCD. I'm pressing the keys on the keypad and you can see that the respective numbers are also displayed on the LCD. Now for the first number, you see that I cannot press more than 7 numbers because we have set the maximum length of each number to 7. Then I press the addition key and the second number. But I don't see my expected results. Let's go back to the code and see where I made a mistake. Okay, here is an error in the test expression of for loop. The test expression in the for loop should check for the count less than length, not greater than length. Now compile the software again and upload it to the Arduino board. Let's test the calculator again with keypad. Addition is working fine. Let's check the multiplication. The results are looking correct. Let's check the subtraction of two numbers. Yeah, and the subtraction is also looks fine. Now it's turn to test the last operator, that is division. The results are also looking fine. You can even see the numbers after the decimal point because we are using type double to save the end results. Let's check the last key of our calculator, that is the cancel key, or you can also say it a reset key that will clear the LCD and also reset our calculator. And we can see that the LCD got clear. I would say this key has done its job. That was all I wanted to cover in this video. I hope you have learned something new from this video and I was able to convey this knowledge to you. This was just a one way to write code for calculator. There are tons of other ways to write the logic of calculator, and I'm sure many of you would be thinking the few steps of this calculator logic could have been improved. If you think so, please let me know in the comment section.